This video is about calculating the area of a circle and of a sector and the circumference and arc length. So first of all, how do you find the area of a circle? Area of a circle is going to equal to pi r squared, where r is your radius. Remember, at the end of your answers, you always need units squared. So feet squared, inches squared, centimeters squared, whatever unit that problem has. So in number one, we want to find the exact area, which means we do not want a decimal. So our area is equal to pi times 12 squared. 12 squared is 144, so I always put the number in front of pi for my final answer. We have 144 pi centimeters squared. In number two, 30 is representing a diameter. So remember, in a diameter, that is made up of two radii, so we're going to split it into 15 and 15. So your area is equal to pi 15 squared. 15 squared is 225, so we have 225 pi meters squared for our area. Now the area of the sector is different. In an area of a sector, we're just looking for a shaded region. We're looking for part of the circle. So in this case, we'd be looking over here to find the area of this sector. So a way to think of area of a sector is like, how big is your pizza slice, or how big is your cake slice? So what you're going to do is you're going to use the area of the circle, pi r squared, measure of the shaded region over 360. So let's look at a couple examples. So in number four, we want to find the exact area of the shaded region. So in number four, we have a radius of 3, and our shaded area has a measure of 80 degrees because the central angle would be the same. So to find our area, it's going to be pi r squared, so pi 3 squared, times the measure of the shaded region, 80 degrees, over 360. So in our calculator, we would type 3 squared times parenthesis 80 divided by 360, and we get 2. Remember to put pi with your answer because we didn't put in the calculator, so we have 2 pi centimeters squared. In number 5, we're looking at the shaded region. So the part that's not shaded is 60 degrees. So if I subtract from 360, 360 minus 60 would be 300 degrees. So we want the shaded region of 300 degrees. So we would have pi 18 squared times 300 over 360. Go back to our calculator. 18 squared, parenthesis, 300 divided by 360. And we get 270 pi inches squared. Our last one, number 6, we have a radius of 30 and the shaded region is 120 degrees. So we have pi 30 squared times 120 over 360. Type that in and we get 300 pi meters squared. Of a circle. Well, circumference of a circle. So to find that, we're going to use circumference equals 2 pi r. When we do this, we need to always have the units. It's not squared anymore because, like perimeter, it's just your regular units. So in number 7, we want to find the exact circumference of the circle. So we would have 2 pi times 10, which would get us 20 pi yards. In number 8, 40 is a diameter, so we need to split that in half into 20 and 20. So we would have 2 pi times 20, which would be 40 pi. Now, another way to find circumference is you can also do diameter times pi if you know your diameter, which in this case, in number 8, then we see is 40 pi. So there's really two ways. The most useful, though, is the circumference equals 2 pi r. So try to use that one the most, but you can also use your other one sometimes if you know the diameter. So arc length, then, is a similar idea to the area of a sector. We're looking for just part of our arc length. So think of arc length as like the crust of a pie or of a pizza. So we would have the circumference still, and then we're going to multiply by the measure over 360. So in number 10, we want to find the arc measure of AB. So we would have 2 pi 9 times 120 over 360. So we're not going to put pi in the calculator. 2 times 9 times 120, parentheses 120, divided by 360 would get us 6 pi inches. In number 11, we want arc EGF. So EGF is going this way around the circle. So if the non-included part is 110, we can do 360 minus 110, which gets us 250. So this is 250 degrees. So we have 2 pi 18 times 250 over 360. So in our calculator, 2 times 18, parenthesis 250 divided by 360, and we get 25 pi feet. Number 12, we're looking for CD, which is 90 degrees. So we would have 2 pi 12 times 90 over 360. So in our calculator, 2 times 12 times 90 divided by 360. And that gets us 6 pi centimeters. In number 13, we want to find a couple of different things. So we want to find the measure of NF. This should always be a degree answer with no pi. So how many degrees is NF of the circle? So if the central angle is 75, this is also 75 degrees. To find your arc length, that's like the pizza crust. So it is 2 pi times your radius, which is 12, times 75 over 360. 2 times 12 times 75 divided by 360. And that gets us 5 pi. And we'll just write units because we don't have any. The area of our sector then is pi 12 squared times 75 over 360, because now we're looking for the actual pizza. So 12 squared times 75 divided by 360, and that gets us 30 pi units squared. So let's look at some word problems. In number 14, the area of the circle is 49 pi. What is the diameter? So in order to find the diameter, we need to know the radius. So remember, area is equal to pi r squared. So 49 pi equals pi r squared. We can divide both sides by pi, so we're left with 49 equals r squared. Take the square root, and our radius is 7. So to get your diameter then, it is 2 times the radius. So it would be 14 centimeters. Number 15, the circumference of the circle is 30 pi yards. What is the area of the circle? So circumference is 2 pi r. So we have 30 pi r. 30 pi equals 2 pi r. We can divide by 2 pi, and we get 15 equals the radius. So your area is equal to pi times 15 squared, which would be 225 pi yards squared. (16) The area of the circle is 100 pi meters squared. What is the circumference of the circle? So our area is equal to pi r squared. 100 pi equals pi r squared. We can divide both sides by pi, which leaves us 100 equals r squared. So our radius is 10. Once we know the radius is 10, we can get our circumference. 2 pi times 10. So we get 20 pi meters for our circumference. 17. The circumference of a circle is pi 50 feet. What is the diameter of the circle? So circumference equals 2 pi r. 50 pi is equal to 2 pi r. We can divide by 2 pi, and we get the radius is 25. So to get your diameter, you multiply by 2, and we get 50 feet. Now with circles, let's look at some questions that have appeared on the SAT. So the first question, in the circle, segment AB is a diameter. If the length of arc ABD is 8, what is the radius of the circle? So ABD is 180 degrees of the circle. So we know that 8 pi is equal to 2 pi r times the measure over 360. Well, we know that the measure is going to be 180 degrees. So we can solve using this. Okay, now when I reduce 180 over 360, I get a half. So we have 8 pi equals 2 pi r times a half. 2 times a half is just 1. So that leaves us with 8 pi equals pi r. If we divide by pi on both sides, we get the radius is 8. In our next problem, the center with circle O has a circumference of 36. What is the length of the minor arc AC? So the minor arc AC is 90 degrees. So if we know our circumference, remember it's 2 pi r times the measure over 360. This is our circumference. So we already know our circumference. So we would have 36 times 90 over 360 because it's 90 degrees for the circle. So we would have 36 times 90 divided by 360, and we would get 9. Now, in this case, it's not going to have pi because the circumference didn't have pi, which is common in SAT questions. Next one, point A and B lie in a circle with a radius of 1, and arc AB has a length of pi over 3. What is the fraction of the circumference of the circle? So we know that our arc length is equal to pi over 3, and we know the equation for that is 2 pi r times the measure over 360. So we know our radius is 1, so we have pi over 3 equals 2 pi times the measure over 360. We can divide 1/3 by 2 pi. So in our calculator, we're not going to put we can put the pi in. So if we put the pi, we have parenthesis, pi divided by 3, close parenthesis, divide by parenthesis, 2 pi, close parenthesis. We get a fraction, so we're going to hit math, enter, enter, and we get 1/6. So we have 1/6 equals the measure of m over 360. We don't need to find our measure of m because we know it's going to be equal to 1/6, so that is the fraction of the circumference. Point C is at the center of the circle. What is the fraction of the area of the circle of the shaded region? So the shaded region is 100 degrees out of 360. We can reduce that, so 100 divided by 360. Math, enter, enter, which would be 5 over 18. In the last problem, in the circle, point A is at the center, and the length of the arc of BC is 2/3 the circumference of the circle. What is the value of r? So we want our angle. So all we have to do is we know it's 2/5 of the circle, so 360 times 2/5. And we get 144 degrees. So because the arc has 144 degrees, the angle is also 144 degrees.